Good afternoon. How are you doing? Welcome to class. Today we are going to look at 4 different aspects. So at the end of today, you should be able to perform some operations with numbers. So we shall also look at exponents, square and cube roots, as well as another topic. Don't forget, in our previous classes, we have looked at fractions, different types of fractions. We've also looked at proportions as well, with unit rates. And I want you to look at this. Our board mass that we discussed is also very essential here into this topic, board mass. Then we are also going to look at these concepts. Plus times plus will give you plus, minus times minus will give you plus, minus times plus will also give you minus, then plus multiplied by minus will give you minus. This will be applied as we continue into this class. So let me go through the introduction. Operations with integers. The set of integers contain the whole numbers and their opposites. 0 can represent ground level with room above and below, such as the rim of the Grand Canyon or the edge of a body of water. 0 can also represent a starting point, and integers represent moving forward and backward, as the case may be. Integers could be the set of all whole numbers and their opposites. Now let's look at this. An object moving forward or up can be represented by a positive integer, while when an object moves backward or down, a negative integer is used. In other words, if there's a ball, if I kick this ball and it's moving towards this direction, and there's a wall here, the ball can rebound back. It can rebound back in an opposite direction. So we just talked about moving forward or going up, meaning that it can be denoted with positive value, and if someone is going down or moving in an opposite direction, it can be denoted with a negative value. So if this ball now is moving with a velocity of, let's say, 2 meters per second, it is a forward movement. As soon as it touches this wall now, it will rebound. So it's moving backward in an opposite direction. So it's going to be a negative value. To be a negative value. So that's what they're trying to tell us in this movement. Let's look at the first example from study material. Look at this example 1. Example 1. What is plus 12 plus into bracket minus 5? Let's take a good look at this. Plus 12 in bracket plus into bracket minus 5. Don't forget our board mass. The board mass is very, very important. Okay? So bracket of division, multiplication, addition, and subtraction. So we'll bring them out. This is still going to be plus times minus. We just said it here. Plus times minus is minus. So plus times minus is going to give me minus 5. Then I have plus 12 here, plus 12. So if I have 12 naira, but I'm owing someone 5 naira, what do you think I'm going to have left with me? I haven't paid 5 naira out of the money I have. So plus 12 minus 5 will give me plus 7. That is positive 7. Positive 7. Or you could write it as number 7. We already know that if an answer is this, it means it's plus 7. We already know that. Is that taken? Good. So let's look at another example. Let's look at another example. Example 2 is saying that, example 2, what is minus 9 minus 2? What is this? Minus 9 minus 2. Question mark. So it's still the same approach. We'll clear the brackets. Minus times minus. From what I said earlier, minus times minus will give us plus. So minus times minus is plus. That's plus 2. Then I bring out this one. I bring it down. That's minus 9. Right? So minus 9 plus 2. What do you think minus 9 plus 2 will give us? I'm indebted to the tune of 9 naira, but I have 2 naira with me. So, I haven't dropped the 2 naira. I will still be owing. How much do you think I'll be owing? I'll be owing 7 naira. So minus in mathematics, we use it to denote debt. So minus 9, I'm owing 9 naira, but I've been able to pay 2 naira out of it. So I will still be owing 7 naira. So my answer will be minus 7. Minus 7. Let's take a good look at how it is being solved. Think of minus 9 as taking 9 steps backward from a starting point. Then subtracting minus 2 will represent undoing 2 of those steps. You can see their own analogy. Meaning you go forward 2 steps. You are going forward by 2 steps. Then the result is 7 steps backward from where you originally started. So they are just trying to, lay much emphasis on how they arrive at minus 7 from what we have in our notes. Now listen to this instruction. When multiplying and dividing 2 integers, the sign of the result depends on the sign of the numbers being multiplied or divided. When the 2 numbers have the same sign, the result will be positive. When the 2 numbers have opposite signs, the result will be negative. It is simply put, if you look at the board, look at this. When the 2 signs have the same sign and you are multiplying, see minus times minus, the same sign, the end result is positive. But we are just being told, look at these 2, they have positive, plus times plus, the same sign, the answer is also positive. But when it have opposite sign, the answer will be negative, as stipulated with that explanation. So this is just a summary of that explanation on the board. Is that taken? So if that is a summary, can we still continue with the examples? Let's continue with the examples. Example 3 is the next one. Example 3 is saying that what is, example 3, what is plus 6 times minus 2? What is plus 6 times minus 2? Now, from this breakdown, from this is our guide. Plus times minus. Plus times minus. We have it on the board. So plus times minus will actually give me minus. So what is 6 times 2? That is 12. So plus 6 times minus 2 will give us minus 12. That's our answer. Hope that is taken. Then the next example, example 4. Example 4 is saying, example 4 says, what is minus 5 multiplied by minus 3? That's question mark. Still the same approach. Minus times minus. They are the same sign. It will give you positive. So minus times minus is plus. 5 multiplied by 3 is 15. So your answer is what? Plus 15. Minus 5 times minus 3 is plus 15. So that is how they arrive at plus 15 in the study material. Now, look at this order of operations. Let's quickly run through. Now, order of operations. You follow the order of operations when evaluating an expression. Perform all work inside grouping symbols, be it parentheses and brackets, following steps 2 through step 4 below. Find the values of powers, that is the exponents. We are going to look at exponents thereafter, and roots. See lesson 24. Then step 3 is saying multiply or divide, working from left to right. Step 4 says you should add or subtract, working from left to right. I'm sure we did something similar while we discussed fractions then. So let's look at this example 5. Example 5. Let's look at this example 5. Example 5. I hope you can see my board. Let's look at example 5. Evaluate. We have 3 squared plus minus 4 in brackets, then 2 also in brackets, then minus in bracket again 4 plus 6 multiplied by 3. So we have been asked to evaluate this. Evaluate 3 squared plus minus 4 in brackets, then another value 2 in bracket, minus 4 plus 2 times 3. Don't forget, BODMAS. Apart from clearing the brackets, multiplication comes before addition and subtraction. So let's bring it down. Taking a good look at this, 6 times 3 is 18. So I will bring it down here. 6 times 3, 18. 18 plus 4 is 22. 18 plus 4 is 22. So the same approach here. They are both in brackets. It means you are multiplying the 2. Minus 4 times 2. Minus 4 times 2 is 8 in brackets. Then bring down this, your positive sign. 3 squared. What's 3 squared? 3 multiplied by 3. That's 9. 9. 3 multiplied by 3 is 9. So if I want to eliminate or remove the bracket, I'm going to have 9 plus 8 minus 22. 9 plus 8 minus 22. What is 9 plus 8? That is 17 minus 22. 17 means plus 17. And this is minus 7. This is minus 22. I have 17 naira, but I'm indebted to the tune of 22 naira. even after paying my 17 naira, I will still be owing. Isn't that so? I will still be owing. Okay? So, how much will I be owing? I'll be owing a sum of 5 naira. So 17 minus 22 will give me minus 5. 17 minus 22 will give me minus 5. So that is how we arrive at this answer. Oh, there's a mix-up. I've ignored this negative here. I've ignored this negative. So this should have given me minus 8. So our answer is going to be changed. It's going to be altered. Minus 4 times 2 is minus 8. Now, if minus 4 times 2 is minus 8, just take a good look at this. Then plus times minus, we have it on the board. Plus times minus is minus. It means this is going to give me minus. This is minus. Is that taken? This is minus. Then definitely we are not going to have the same answer. It means that this is the only positive value I have, plus 9. So I will rewrite it. Minus 8 minus 22. I'm owing Taiwo 8 naira. And at the same time owing Idowu 22 naira. How much is my debt altogether? So how much is my debt altogether? I'm owing someone minus 8 naira, owing another person 22 naira. That's going to give me minus 30. I'm owing 30 naira altogether. But I have 9 naira with me. So after making that payment of 9 naira, I will still be owing, because the amount I'm owing is much more than the amount I have. So 9 minus 30 will give me minus 21. 9 minus 30 will give me minus 21. So that is minus 21 for that example 5. Now, having done that, let's look at the practice questions. Let's look at the practice questions. So for question 1, choose or write the answer to each question. For question 1, which of the following, question 1 now, which of the following is equal in value to, let's look at it, this is minus 6 in brackets, minus plus 9, plus 12, then minus 4. So take a good look at this. Minus 6 in brackets, minus plus 9 in brackets, plus 12 in brackets, minus 14. Let me write it. I think the video is okay. You can see it. You can see it now. Let me bring it down. Good. So let's open up all the brackets. This is minus 6. Minus times plus will give me minus. I bring out my 9. Plus times plus still remains plus. I bring down my 12. Minus times minus will give me plus. I bring down my 4. Now let's look at this. Minus 6 minus 9. I'm owing Taiwo 6 naira, and at the same time owing Idowu 9 naira. How much am I owing altogether? So I'm owing 15 naira. But I have 12 naira, and at the same time I have 4 naira. So how much do I have altogether? If you add up these two, it's going to be plus 16. Now take a good look at this now. Minus 15 plus 16. I'm owing someone 15 naira, but I have 16 naira. Now, if I pay my 15 naira, I'll still be having some money left with me. So how much am I having left? That means I'm going to have 1 naira as the money left with me. And that goes for option D. Option D is the correct option in that question. Hope that is noted. Let's go to question 2. Question 2 is saying, which of the following is equal in value to 18 is in brackets, minus 5, minus 3, plus minus 7. So let's take a good look at this. You also eliminate the brackets. You remove the bracket. 18, you bring down your 18. Minus times minus is plus. Bring down your 5. Minus times minus is plus. Bring down your 3. Plus times minus is minus. Bring down your 7. Hope that is taken. Now, these are all positive values. 18 plus 5 is 23. 23 plus 3 is 26. That's 26 minus 7. So what is 26 minus 7? 26 minus 7 is 19. And what option is 19? That's option A. Is that taken? That's option A for question 2. Let's go to question 3 very quickly. Question 3, let's see what's in question 3. Let's see what's in question 3. Question 3 says, which of the following is equal in value to minus, that's question 3, minus 8 in brackets, minus 4 in brackets, then minus 2. They are all in brackets. You can see this is interesting. So since they are all in brackets, it means products. You multiply everything. You multiply everything. So listen and listen attentively. Minus times minus is what? Plus is on the board. Then plus times minus is minus. I repeat again. Minus times minus is plus. Plus times minus is minus. So that means 8 times 4 is what? It's 32. 32 times 2 will give me 64. So your answer is minus 64. You can see they wanted to trick you. Option A is saying 64, positive 64, while option D is saying minus 64. So minus 64 is the answer. Minus 64 is the answer. Minus times minus is plus. Plus times minus is minus. Then you now multiply through all the values and you arrive at your answer. What's question 4 saying? Question 4 says, which of the following is equal in value to 6 plus 8 multiplied by 2 squared? 6 plus 8 multiplied by 2 squared. Your board mass. Don't forget, your multiplication is very important in board mass. But you have to square this. 2 squared means 2 times 2. So it means 6 plus 8 times 4. 2 squared. 2 times 2 is 4. Right? So multiply it by 8. What is 8 times 4? 8 times 4 is 32. 32 plus 6. 32 plus 6 will give me 38. That will give me 38. And what option is that? That's option B. Option B is the correct answer in that regard. Option B is the correct answer in that regard. Now let's go to another question. Question 5. For question 5, let me clean the board. Question 5. Let's see what question 5 is saying. Question 5 says, which of the following is equal in value to minus 2 times 5, all being squared? You can see this is interesting. Plus minus 3 times 6 minus 2 times 5 all being squared plus minus 3 times 6. Let's deal with each of the brackets. Let's solve it. This is minus 2 times 5 is going to give me minus 10 all being squared plus minus 2 times 6 minus 3 times 6, that's minus 18. Minus 18. Now, minus 10 squared simply means minus 10 times minus 10. Can you see that? Minus 10 times minus 10. Minus times minus is what? Plus. 10 times 10 is 100. Now, take a good look at this. Plus times minus will give me minus 18. Plus times minus is minus. Is that okay? Then you have your 18. Bring your 18 down. Plus 100 minus 18. That will give you 72. 72. And which option is 72? Which option is 72? 72 is not in the option. 72 is not in the option. So that means the options, there's no correct answer in the options. Is that okay? No correct answer in the option. Going by this. Going by what you have solved on the board. Or did you make any mistake? I don't think so. Minus 3 times 6 is minus 18. This is minus 10 squared. Because both are affected by the square. So that is minus 10 times minus 10, that's plus 100. Then minus 18. Okay, that's 72. So you can see they wrote 82. Sorry, it is 82. 82 and not 72. There's correct answer. It's 82. 82, sorry. 82, if you add 18 to it, you get 100. Okay, 82, that's option A, is the correct answer. 100 minus 18 is 82. Option A is the correct answer. Sorry about that. Sorry about that. Let's proceed to question 6. Question 6. Let's proceed to question 6. Let me clean the board. Question 6. Let's proceed to question 6. Question 6 says 2 raised to power 3, that's 2 cubed, minus, then minus 25 over minus 4 plus 9. This is interesting. 2 cubed. 2 cubed is still the same thing as 2 times 2 times 2. Is that okay? 2 raised to the power of 3 means 2 times 2 times 2. That is 8. Then minus, we have minus 25 as the numerator. Now this is minus 4 plus 9. I'm owing someone 4 naira, but I have 9 naira. If I'm able to pay the 4 naira, I should still have some money left with me. So minus 4 plus 9 is plus 5. Plus 5. Minus 4 plus 9 is plus 5. Don't forget, division is coming in place. Division comes from our board mass, division. So now look at this. These 5 in 5, 1, 5 here, 5. So I'm going to have 8 minus 5. 8 minus 5. 8 minus 5 is 3. So 8 minus 5 is 3. That is option C. Option C is the correct answer there. Hope that is noted. Option C is the correct answer. Question 7 is like a word problem. Let me read it out. Question 7, like a word problem. The lowest elevation of a desert is 250 feet below the sea level. The highest elevation is 1,000 feet above the sea level. We're now being asked to find the difference. What's the difference in height between the highest and the lowest point? Now, they gave us a hint that think of sea level as 0 feet. Think of sea level as 0 feet. So what's the difference between 1,000 feet above the sea level and the 250 feet below the sea level? So question 7 is going to be 1,000 minus 250. 0 minus 0 is 0. 0 minus 5 impossible. We'll come here to borrow 1. I'm left with 9 here. So when it gets here is 10. 10 minus 5 is 5. Then 9 minus 2 is 7. So it's going to give us 750 feet. 750 feet as our answer. 750 feet as our answer. The last question under the practice question talks about, is also a word problem format. A word problem format, let's see the question together. Word problem format. Nita had $318 in her checking account. So it's a plus to her. On Monday, Nita had $318 in her checking account on Monday. On Tuesday, she withdrew $60. So this was on Monday. So on Tuesday, she withdrew how many dollars? $60. Then Nita decided on Wednesday to deposit. She deposited on Wednesday. She deposited $289. $289 on Wednesday. And made a purchase. You can see that same Wednesday she deposited $289 on Wednesday, and at the same time she did this simultaneously. She made a purchase of 50 naira, a purchase of $50 rather, on that same Wednesday with her debit card. What was her balance after using her debit card? So let's look at this. This $289 happened to be a deposit with what she had in her checking account as at Monday. So we need to add up this $318 with $289. So let's sum that one up. Plus 8 plus 9, that's 17, remainder 1. 2, that's 10, remainder 1. 4, that's 6. So Nita had $607. But she made a purchase of $50. She also withdrew $60. So if you sum up 60 and 50, that's $110. So that is subtraction, $110. She made a withdrawal and she made a purchase respectively. So let's subtract that. That's 7. Borrow 1. We are left with 5 here. This is going to be 9. And this is going to be 4. So Nita will be having $497 in our bank account after the last purchase she made. She will be having $497 in a bank account or in a checking account. So that is all about the operations with integers or numbers. Let's go to the next lesson. The next lesson is on exponents. Exponents. That's the next lesson. Are we there? Exponents. Hope you can see my board. I think it's high up there. Let me tilt my camera. So, then the introduction. Exponents are used to simplify problems that call for repeated multiplications. I'm sure you are familiar with this, you've done it before now. The expression, look at this expression, 5 raised to power 3, which is read 5 to the third power. It's still the same thing as 5 being raised to the power of 3, or 5 cubed, as it is stated in the study material, has a base of 5 and an exponent of 3. Exponent of 3 or power of 3. Base of 5. So the exponent tells us how many times the base should appear in the multiplication process. So what this simply means is that the base is 5, the power is 3. So it simply means that the base should be multiplied by itself how many times? 3 times. So that's what it means. If you multiply the base by itself 3 times, you will definitely get your answer. 5 raised to power 3 means 5 times 5 times 5. And what do you think that will give us? 5 times 5 is 25. 25 times 5 is 125. Is that okay? So 5 cubed will give us 125. The same thing. Further examples given. 12 squared means this is the base, this is the power. Is that again? So you can even say that 12 superscript 2. Super is power. Subscript is at the base. So this is 12 squared, or 12 superscript 2, or 12 raised to power 2, meaning 12 times 12. And 12 times 12 is 144. Then we also have 2 raised to power 5. It means 2 times 2 times 2 times 2 times 2. 2 appearing 5 times. 2 appearing 5 times. It means 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, that's 32. So 2 raised to power 5 is 32. Is that noted now? So that's what exponent is trying to tell us. Let's look at another tip, another study tip. Exponent, a raised number at the right of another number, that tells how many times the number is to be used as a factor. A raised number, see, 5 is being raised to the power of 3. So it's just trying to shed more light on what you have just done. Now, to raise a number to the second power, use the x raised to power 2 key. Then find the value of 13 squared. It means 13 times 13, which will give you 169. To raise a number to a higher power, use this. Is on the calculator. The key on your calculator, this key, you can say 2 raised to power 3, right? This is the power. 2 raised to power 3 is on your calculator. If you check your calculator, you see it there. 2 raised to power this one. That's what they are trying to tell us on that study tip. Is there on your calculator. Look at it here on my own calculator. Look at it. Is there 2? If I say 2 raised to the power of 2, that will give me 4. 2 raised to the power of 2. This is the symbol. This is the sign. This symbol here. This one. So is that okay now? So you can use that. You can also use exponential, but when that time comes, I will explain. I will shed more light. Like if I say 2 times 10 raised to power 5, So I can decide to say 2 exponential 5. The exponential has taken care of that 10 raised to power. Is that taken? But when the time comes, exponential 2 exponential 5 means 2 times 10 raised to power 5. So let's continue. So that's what they're trying to tell us in our study material, that you should use this key 2 raised to power, An exponent can also be 1, 0, or negative number. Yes, depending, because I can have 2 raised to the power of minus 3. One of the laws of indices. Any number except 0 with an exponent of 0 equals 1. 4 raised to power 0 is 1. From what we have in our study material, they are trying to shed more light on what exponent means to us. Is that taken? Trying to shed more light. 2 raised to the power of 1 is 2. 9 raised to the power of 1 is 9. Because you have to repeat it just once. Unlike when we add 5 raised to the power of 3, we said 5 times 5 times 5. And we ended up having 125. Is that taken now? So, then any number raised to the power of 0 is 1. 10 raised to the power 0 is 1. 4 raised to the power 0 is 1. Is that taken? So, this can be proven using one of the laws of indices. Any number raised to the power of 0 is 1. So that's what we have in our study material. Our number system is based on the idea of grouping by tens. Grouping by tens, you can see what is discussed there. Grouping by tens, powers of 10 are especially important. They're especially very important because you may likely come across that. So that is why, let me shed more light. 10 raised to the power 1 is 10. 10 raised to the power 2 means 10 times 10. That's 100. 10 raised to the power of 3 is 10 times 10 times 10. And that is 1000. And 10 raised to the power 4 is 10 times 10 times 10 times 10. That is what? 10,000. So considering how many? The power 4 zeros. The power 3 zeros. The power 2 zeros. Then when it is 1 0. So that is what we are trying to explain there. Then when we have negative powers of 10, they are also useful for writing very small numbers. Any number to a negative power represents a fraction or decimal. Represents a fraction or decimal. Taking a look at this from what is stated, when we have 10 raised to the power minus 1, it means that 1 over 10. 1 over 10 in decimal. Since it is just 1 0, I move the decimal once. An imaginary point here, move it once from right to left. So it's going to give me 0.1. Is that taken? So 1 divided by 10 is 0.1. So if I have 10 raised to the power minus 2, it's still the same thing. 1 over 10 raised to the power 2 is still the same thing as 1 over, earlier we said 10 raised to the power 2 is 100. Is that also? Then, because there are 2 zeros, move the decimals. 1, look at this. Can you see my board? Move the decimal. 1, 2. So the decimal is there now. Put 0 here, put 0 here. So you are going to have 0.01. 1 divided by 100 is 0.01. Is that taken? So that is how they arrive at 10 raised to the power minus 3 is still the same as 1 over 10 to the power of 3 is 1000, right? Then if you have to move your decimal, 1 is there, move it 1, 2, 3. Your decimal is there now, 0, 0, 0. So you end up having 0.001. 1, 2, 3. So that's 10 raised to power 3. So you could have negative powers of 10. Negative powers of 10. And that is what is now leading us to another subtopic. Let's look at some things were written. Let me quickly read them out. The exponent for a power of 10 is the same as the number of zeros in the product. So look at this now. They wrote 10 raised to power 6. 10 raised to power 6. So considering how many zeros, there's going to be 6 zeros. 6 zeros. That's 1 million. 10 raised to power 6 is still the same thing as 1 million. Then scientific notation. If I now begin to write 10 million, or I want to write 1 billion, then I must leave it in standard form to make it easier for me. 10 raised to power 6 is in standard form because you cannot begin to write 9 zeros or 12 zeros in zillions, in trillions. So the numbers will be too large. Because of that, we tend to now shrink it into standard forms. Scientific notation, a way of writing very large numbers and very small numbers and very small decimals, in which the numbers are expressed as a product of a number between 1 and 10 and a power of 10. Scientific notation, or what we call standard form, is still the same thing. So taking a good look at the negative value that we just discussed, the negative exponents for a power of 10 and the number of decimal places are the same. 10 raised to power minus 4. Look at this, 10 raised to power minus 4. We said earlier, 10 raised to power minus 4. We said, if I have to do this, it's easy. So it's still the same thing as 1 over 10 raised to power 4. And 1 over 10 raised to the power of 4 can still be further broken down as 1 over 10,000. So if you divide 1 by 10,000, 0.0001, the 4 zeros will still appear. So the 4 zeros will still appear. Hope you can see my board, and the 4 zeros will still appear. So that's what the explanation is trying to say. Now let's have an introduction to the scientific notation. Scientific notation is a method that uses powers of 10 to write very small and very large numbers. A number in scientific notation is expressed as a product of a number between 1 and 10 and a power of 10. Scientific notation. Let me clean the board. Let's see this. Let's see this example given. So we have this is about 900, comma 000 000. So we have to write it in scientific notation. If we have to write this in scientific notation, so what are we supposed to have? So how many zeros are there? About 8 zeros. So you move your invisible points. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 4.9 times 10 raised to the power of 9. So this is in ordinary form. You now want to express it in standard form or scientific notation, as the case may be. Is in ordinary form, but you have now been able to express it in scientific notation. Is that taken? Okay. So this is 4.9 times 10 raised to power 9. you move from right to left. But let's look at this ordinary form, 0.0055. We have to write this in scientific notation. Because you are moving from left to right, it's going to be negative. If you move from right to left, that's positive. But now you want to move from left to right. Look at this. 1, 2, 3. So 5.5. How many times have we moved the point? 3 times. But it's going to be minus 3. 5.5 times 10 raised to the power minus 3. We move 1, 2, 3. Because we are leaving it in standard form or in scientific notation. And don't forget, scientific notation is a method that uses powers of 10s to write is either is a very small number or a very large number, such that we express it. The number is between 1 and 10 and to the power of 10. Okay, I haven't said that. Let's see. Okay, there's another. Let's discuss the difference to the sum is about this. Okay. The distance to the sum is about 93 million miles. 93 million miles. Is that not? The distance to the sun is about 93 million miles. Write this distance in scientific notation or write it in standard form. So if I'm to write this in standard form, I'm moving from right to left. So look at this. 1, 2, 3, 4, 5, 6, 7. I'm going to have 9.7 times 10 raised to the power 7. So that's how I'm going to leave that in scientific notation or standard form. Is that taken? Is that taken? Good. So, do we have another one? Okay. Now, this one, we have to express this in an ordinary form. Ordinary form. We have 2. Okay, let me clean the board so that, or let me write it here. 2 times 10 raised to the power minus 5. 2 times 10 raised to the power minus 5. So, we have to write it in an ordinary form. So, once you see this, and 10 raised to the power, this it means it's going to be 5 zeros. I can break it down by saying this is still 2 times 1 over 10 raised to the power 5. We said it earlier. It's still the same thing as 2 times 1 is 2 over 10 raised to the power 5. It's still the same thing as saying 2 over 10 raised to the power 5 is 100,000. Can you see that now? So 5 zeros. Put your 2, 1, 2, 3, 4, 5. Your decimal is there. 0, 0, 0, 0. So you end up having 0.00002. So you can still see 1, 2, 3, 4, 5. So this is how you write that in ordinary form. This is how you write that in ordinary form. 2 times 10 raised to the power minus 5 should be written in an ordinary form. It's in standard form or scientific notation, as the case may be. So you may be asked to write it in an ordinary form. Is that okay? So this is how you go about it. 2 times 10 raised to the power minus 5. It's still the same thing as 2 times 1 over 10 raised to the power 5. Then 2 times 1 is 2. 10 raised to the power 5 is 10. So 10 raised to the power 5 is still the same as 100,000. So if you divide 2 by 100,000, you end up having 0.00002 as your answer. Is that taken? Let's take a look at this. If you perform operations that result in a very large or very small number, your calculator may display the solution in scientific notation. That is true. because the larger the number, the result will be processed such that it will not be given in scientific notation. So look at this question given. Look at this question given. We have 30,000 multiplied by 5 million. See, 30,000 multiplied by 5 million. So what you need to do is this: 30,000 multiplied by 5 million. What you need to do is look at this. This is 3, this is 5. What is 3 times 5? 3 times 5 is 15. Then how many zeros do we have? I will recopy the zeros. How many zeros? There are 6 zeros there, right? Then there are 4 zeros, making 10 zeros. I'll write out 10 zeros. 6 times 4, 5, 6, 7, 8, 9, 10. Don't forget, these are 6 zeros. These are 4 zeros, making 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. This is 150 billion. So if I'm now to express this in scientific notation or in standard form, I move this way from right: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's going to be 1.5 times 10 raised to power 11. That's how they arrive at that answer. Okay, let's quickly go to our practice questions as usual. So the question says, choose or write the answer to each question. Do not use a calculator. So we've been instructed not to use a calculator. So since we have been instructed not to use a calculator, we have to find another means of solving it. Is that okay? Let me clean this part. I hope you understand this part. Let me quickly clean it. So we have the first one. Question 1 is saying 2 raised to power 4. You already know that 2 raised to power 4 is still the same thing as 2 times 2 times 2 times 2. 2 written in 4 places. Then we multiply it out. 2 times 2, 4. Times 2, 8. Times 2, 16. And what option is that? Option D is the correct answer. Can you see that? Option D is the correct answer. Then the next one is number 2 is 4 raised to power 3. That's 4 cubed. 4 raised to power 3 is still the same thing as 4 times 4 times 4. 4 raised to power 3 is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. What option is there? That's option D also. Then the next one is saying, question 3 is saying 16 raised to power 1. Don't forget, since it's 16 raised to power 1, it will end up giving us 16. And the correct option there is option C. Can you see that? Number 4, there is 1 raised to power, is it 8 or 6? 1 raised to the power of 6. It means 1 times 1 times 1 times 1 times 1 times 1. Anything multiplied by 1 is that number. So 1 into 6 places will still give us 1. And that's why the correct option is option B. Then the last one, which is 5 raised to power 0. Anything raised to power 0 is 1. We said that earlier. And that is option C also. So we've been instructed not to use a calculator in this part. So, okay, there's one more there, the one that has a negative value. That's question 6. Question 6 is saying 3 raised to power minus 2. 3 raised to power minus 2 is still the same thing as 1 over 3 raised to power 2. 1 over 3 raised to power 2. Can you see that? So it means 1 over 3 raised to power 2 means 3 times 3. That's 1 over 9. And what option is that? Option B. Option B is the correct option. Option B is the correct option. Is that taken? Is that taken? Let's look at other questions there. Let's look at other questions there. So, the distance across the sun, in bracket, its diameter, in scientific notation, is 8.65 times 10 raised to power 5 miles. What is the distance written in standard notation? Standard notation in this context means in ordinary form. How do you now write 8.65 times 10 raised to power 5 miles in standard notation or in an ordinary form? In an ordinary form. So let's take a good look at how we can do that. 8.65 is quite easy. 8.65 times 10 raised to power 5. So I can bring down my 8.65. It means that I'll move this decimal to the right 5 times because there are 5. The power is 5. So let's go. 1, 2, 3, 4, 5. Then I'll put 0 here. The decimal is no longer here, but rather it is here now. So then I write out my numbers. 8, 6, 5, 0, 0, 0. You can see it is now going to be 1, 2, 3, 865,000. 865,000. I move this decimal 5 times because the exponent is 5. The power is 5. So I move it. The movement is 1, 2, 3, 4, 5. And I added 0 here. So, and what do you think the correct option will be? 865,000. You can see they want to confuse people. They still left some answers in scientific notation, but people will get confused. And the correct answer there is option C. Option C is the correct answer. Is that taken? So look at question 8. In very dense fog. In very dense fog, a person cannot see about 0.019 mile. And because the weather is foggy, it won't be visible if you are driving. It's foggy everywhere. It's still very, mist is everywhere. So what's the distance written in scientific notation? How do we go about this? This one, you should know that we are moving from left to right. Look at this. 1, 2. So it's going to be 1.9 times 10 raised to the power minus 2. The movement is just twice. And the correct option is 1.9 times 10 raised to the power minus 2. Option A is the correct option there. Option A. You can see option D is looking like it. But 19 times 10 raised to the power minus 2 is not written in standard notation. 19 times 10 raised to the power minus 2 is not in standard form or scientific notation. No. Is that taken? It must be between 1 and 9. 19 is not between 1 and 9. Okay? So that is how we go about it. So look at this question. We ask to arrange the given numbers in order from least to greatest. I'm going to allow you to do that. Question 9 and question 10 is going to be part of your exercise. Arrange the given numbers in order from least to greatest. That's in the box. You just drag and drop. 5.4 times 10 raised to the power 2. 3.02 times 10 raised to the power 3. 9.55 times 10 raised to the power minus 2. That's for question 9. And for question 10, choose the option that best completes the sentence. 4.2 times 10 raised to the power 2 is it more than 42,000? Is it equal to 42,000 is it less than 42,000? So I want to believe at this junction you have learned one or two things. We are going to call it a day from here. In our next class, we're going to look at square root and cube roots. Square root and cube root. Until then, do have a wonderful day. Thank you very much, and God bless.